Okay, so we are gonna do 150 questions. I have done few of them before, so I am trying to crack an entry interview. Also, I just want to mention that I'm from a tier 3 college and trying to get a tech job. So, grinding lead code is the best thing I can do now. So, here is the problem today. I'm doing the first problem more shorter array by spin. Go through the thing and just look at this. So here is the problem. So the problem statement says that you are given two integer arrays, nums1 and nums2, sorted non-decreasing order, and two integers m and n. So here you can see two integers array. This is nums1, this is nums2, and two integer m and n. Right? Don't look at the solution right now. Okay. So I'm learning through you guys. I'm learning through these videos also. These are like helping me to build my logic. So please, anything you want to say to me, just comment and things like that. So here M1 represent the size of the non-zero element of the first array. N represent the size of the second array. Right. Now what we'll do is we're gonna do two pointer approach. Okay. So what is the two pointer approach says? We are gonna uh make pointers. One is P1, one is P2, and another one is P. Okay. So what P1, P2, and P represents? P1 would be M minus 1 place. P2 would be N minus 1 place. M and N are the size of the arrays. And P would be at the like end of this first array. We can say it as like and the P's location would be M plus N minus 1. Okay. So just remember this. Now what happens? Now comes the logic, how this thing works. Here P is 0. We know that. We would compare P1 and P2, right? We are going to see if this P1 and this P2, okay, these are, which one of these are bigger, right? So here we can see there is 3 and there is 6. So always we know that 6 is bigger. So we will replace P with the bigger one like P2 over here. Replace P with P2, right? Now P1 would be minus minus as P1 was the smallest. So we're going to move the P1 and then this loop will continue. Now after this, what would happen? P would be minus minus as we know P also goes from here to here. Now we will again check if P1 is greater than like P2 is not, then what would happen? We will gonna like change, yeah, so so here were we again, yeah. So now it is on P1, right? Now it is this P2 which is 5 and P1 which is 2. Obviously 5 is bigger, so we'll replace the P with a 5 and then P2 would be minus minus, P2 would be over here. Sorry, P1 still would be 3. We'll compare 3 with the 5 as P1 didn't change. P2 is changing. We are comparing P2. Here P2 is 2 and P1 is 3. So here, which is the smaller one? P2 is smaller one. So we are gonna change the first time for the P2, which is 2. sorry, P1, which is 3. So here would be 3. And this would become. So here what is happening is, here is P2, which is 5, and here P, which is 0, and P1 is 3. Now in this case, if we see, let's say P1, which is less than P2, right? P1 which is P2. So for P1 less than P2, what we'll do, we'll just change the P, we just change the P, we'll just change the P with the P2, as we have to just get which one is the bigger, right? P2. So then what would happen? This 0 would be P2. Now in the next portion, y P will be shifted to here, this will shift it to here, P2 will shift it to here. Now again we check, is P2 greater than P1? No. So what would happen? Then we will just exchange the P with the P1, which is 3. So the 3 would be over here. And then after that, P would go over here. Then this thing will look at over here. Is the P1, which is right, P right now, whatever, P1, 3 greater than 2? No. So it will gonna be 2 over here. That is the whole thing about this thing. There is another thing, if nums2 still has element left, uh, while P2 greater than is equals to 0, means P2 is not became 0, nums1 is equals to nums2p. Here this case happening, nums1p is equals to nums2 P2, right? So P minus minus and P2 minus minus. So this is the whole thing about this code. If you didn't understand, I can go through it again if you want. So let me know. So the overall thing is, we just get the P assigned to here, P2 assigned to here. Is P2 greater than P1? Yes. Then we set it over here. Again, P2 minus minus. Is P2 greater than P1? Yes. Then set it over here. Again, over here, if we just take the arrow over here pointed, P2 greater than P1? No. Then we set P1 to here. We then check again, P2 greater than P1? No. Then set. So this is the whole thing about the problem. So we'll just implement this thing, right? But first we have to say what is P1 and P2. P1 is M minus 1. P2 is, sorry, I have to put say int. P1 is N minus 1. And int P2 is M minus 2. Right. E is N plus N minus 1. Sorry. So this would be N minus 1. And let's check. Okay, so there seems to be a problem. Hmm. Yeah, so that's it. This is the two-pointer approach. We'll be back with like other problems. Let me know if you guys learned anything else.